Hello, discrete math fans. Let's prove that if we take three consecutive integers and multiply them together, we're always going to get something that's divisible by 6. So to prove this, let's let n be the first of the three integers. So now the product of three consecutive integers is n times n plus 1 times n plus 2. And what we'll do is we'll show that that's divisible by 6. Now we can accomplish this by showing that this product is divisible by 3 and divisible by 2. And you might want to think for a moment to see why that's the case, that it suffices to prove these things. Now the book goes through a very careful proof to show that the product is divisible by 2, so all we're going to do here is show that this product is divisible by 3. Now, the quotient remainder theorem tells us that we can write n as 3q plus r for some q and r in the integers, and r has to be between 0 and 3, not including 3. So really, there's three possibilities for the remainder. R could be 0, 1, or 2. Now we're going to consider these as three separate cases. So in the first case, or maybe I'll call it the 0th case, we'll see what happens when r is equal to 0. So that means n is equal to 3q for some integer q, and then we can say that n times n plus 1 times n plus 2 is 3q times 3q plus 1 times 3q plus 2. Well, here's our factor of 3 that we were interested in, so this whole thing is divisible by 3. What about when r is equal to 1? Then n is equal to 3q plus 1 for some integer q. And now we can say that n times n plus 1 times n plus 2, that's 3q plus 1 times 3q plus 2 times 3q plus 3. And what you can see is that we can factor a 3 out of the 3q plus 3. You see how the 3q plus 3 turned into q plus 1? That's because this 3 got factored out. And now this expression is divisible by 3. Our final case is when r is equal to 2. And in that case, n is equal to 3q plus 2 for some integer q. And that means now n times n plus 1 times n plus 2 is equal to 3q plus 2 times 3q plus 3 times 3q plus 4. So now what are we going to do? We're going to factor a 3 out of this piece here. So that's what we've done. We factored a 3 out of this piece here, and we ended up with a 3 out in front. And so that tells us that in this case also, n times n plus 1 times n plus 2 is divisible by 3. So in each case, we found a factor of 3, and so for every integer n times n plus 1 times n plus 2 is divisible by 3. So this is a very common thing that we may have to do, is to break up our proof into different cases, especially in the context of the quotient remainder theorem, where we don't know what the remainder is, but there are only a certain number of possibilities for the remainder. Okay, that's all for now.